Alright guys, this is Rahul here, and in this particular video I'm going to talk to you guys like about this OIDC flow. And if you guys think like JWT is authentication, then this video is definitely for you. So most .NET tutorials, what happens is they jump straight into that token authentication without even explaining the flow. And that is why I thought to explain you this the sequence diagram first, and like how the interaction between the user and the client app happens, and then how this authorization servers comes into the picture, and how this protects your API, and then JOKS endpoint, which is the last piece which you are seeing here, how this is going to validate this entire piece over the layer, right? So this is where I think this has become insanely important to understand this particular flow with the sequence diagram itself. And then once you have this understanding, because this is the framework piece, I mean, like whether you apply this particular principle in .NET or Java, this is going to remain the same for any of this implementation practice. And this is from that where it is going to differ from implementation to implementation, but under the hood principally it remains the same across any stack. So that is why I thought to get started with the basics and then come to that implementation part. Now what happens, like in this video I will first of all walk you through the correct production grade chart flow using OAuth 2.0, then OpenID Connect, and then obviously this PKCE, and then JWKS, right? And the modern way .NET APIs are actually secured in systems like enterprise systems. So no shortcuts, no magic libraries, just the real architecture in talk here. Now, the very first, strategy here is obviously to explain you the flow from here, right? So let's see, this is the very first actor, which is the user, which I'm explaining here, and how this interaction between the user and the client app is happening, right? So a user tries to, access a secured feature in client application, and this could be, the client application could be in a spa or a web app or a mobile app. It could be anything, right? So the client has no valid access token, right? So it cannot call the protected API, which is this one, which you are seeing here. Now, the fact of the matter is, in between this, yeah, it will try to get itself authenticated, right? The user will try to get authenticated, and where in this authorization server will fall in place. So this is what is happening, like via this OIDC is coming into the picture. But that is where the interaction between the client app and authorization server starts, and that is pretty important, right? So the client redirects the user to the authorization server, right? And that is using this OAuth 2.0, which is authorization code flow, and with PKC mandatory for public clients. And PKC is basically proof key for code exchange. And just to give you a snapshot of that, what PKC is and why PKC exists. So the real problem is like why PKC exists, if we have to answer that one. So confidential clients, client server apps, or server side apps, right? A server could be a safely stored, right? A secret could be safely stored, right? So that assumptions breaks completely for spas, mobile apps, and the desktop apps. So these are public clients, they cannot safely store secrets, right? So that is the main problem. So without PKCE, which is like proof key for code exchange, authorization codes can be intercepted, right? So that's the main problem. Attackers can exchange stolen codes for tokens, right? So this is known as authorization code interception attack, basically. And that is where PKC prevents these things. So what PKC is binds is the authorization code to the original client that requested it, right? So even if someone steals the code, they cannot use it. So that is what the PKC does. And how PKCs work simplified, because what happens, like client generates a code verifier, which is a random string here, which you can see here, which is basically a randomness, going to be a randomness, and that is what you are going to see in the code when you are going to interpret it. And then client sends a code challenge, which is a hashed verifier during the login redirect itself. Then what will happen eventually, that authorization server stores the challenge, which is this one, right? And when exchanging the code, when the code is getting exchanged, right? So what happens, like if verifier doesn't match, that token exchange fails. So that is where PKC is very much mandatory today. Like, and it's been since ever since we have this client app into picture, right? And that is the main distinction factor here, because many people directly jump to this JWT authentication piece and started implementing that this is the fact and this is PKC is by default is mandated, but nobody talks about why it is mandated. So that's why I thought to, draw the line here and explain you this bit, which is pretty important. And this is recommended even for the confidential clients, eliminates the need for client secrets in browsers, and protects against code interceptions and replay attacks, right? So, any modern apps which is getting designed, right? So this is that, this is the piece which is pretty important here. Now, the thing which we were discussing here is that, authorizations, a client app and authorization server, this interaction, right? So what is happening here, this redirects contains basically, the client ID, the redirect URI, and the scopes and the PKC is challenged, right? So PKC, we have already understood that. So at this point of time, no credentials are handled by the client app. So you need to understand this pretty much, exclusively, right? No credentials are handled by, your the client app, which could be a spa, web, or mobile. So when user to authorization server, which means like user to authorization server interaction, which is happening, which is the step 3 and 4, right? So this is where that important thing starts happening. Like, so the authorization server now takes the complete control. So it has become the in charge. So user enters credentials, MFA may happen. So that is where this is happening. Like, so the consent screen and other pieces can be shown here. So this is the real authentication. Now, important point to emphasize here and to remember here is like JOT has not appeared yet. Authentication happened before JOT exists, right? So this is, you need to understand, like authentication happens before JOT exists. Now the next step which comes is the step 5, right? So wherein authorization server and the client app interaction happens, right? And after successful authentication, right, the authorization server sends back a short-lived authorization code. There is an exchange code for tokens which is going to happen, right? So that is where, and this code is basically, since this is going to be a short-lived authorization code, and this code is basically useless by itself. So it cannot be used without PKCE verification, right? So that is where PKCE is pretty important. Now in a step 6 and 7, which you are seeing here, right? So the client app and authorization server. So the client exchanges the authorization code for tokens, right? And the authorization server issues, access token, which is chart meant for APIs, right? So access token meant for APIs, this is a distinction factor, just make it, take a note of that. And refresh token meant only for client, right? Refresh token doesn't mean for APIs, right? And important rule to say is explicitly here is like explicitly need to mention here, like access tokens go to APIs, refresh tokens never do. So many people, gets confused between this. So whenever you get asked these questions in, in your interviews, and this is, as I said, like this is framework agnostic, whether you do in Java, whether you do in .NET, these principles remain the same, and that is not going to change. So now then step 8, which is like API call with JOT, right? Which you can see that the HTTP call, request, which is going with the authorization bearer token as part of this header, right? So this is where, with authorization token, which the bearer token goes is, this is the only thing that API receives, which means there's going to be no cookies, no sessions, no calls to the auth server, right? Now step 9 and 10, right? So step 9 and 10 wherein API fetches that. So the API need to verify basically, was this token really issued by a trusted authority? And how it does is like, so it fetches the public signing key from the JOKS endpoint. Now, in order to understand what is JOKS, first of all, understand its full form, like it's JSON Web Key Set. is that JWKS acronym and why this JWKS exist. What was the core problem? So JWTs are signed by an authorization server, validated by APIs. But API must answer one critical question like how do I know this token was signed by the real issuer? So hard coding key like is going to be unsafe, non-scalable, and breaks key rotation as well, right? What JOKS actually does is JOKS is a public endpoint that exposes a public signing key, right? And that is used to verify JOT signatures. It allows APIs to validate tokens offline, supports key rotation, trust tokens without calling the auth server. So how JOKS works exactly is like authorization server signs JOT using a private key. So and then the corresponding public key is exposed via JOKS endpoint. API fetches and caches these public keys. API then validates JOT signature using the correct key, which is the KID, which you can see here, right? So that is what the public key which is going to be validated against, and that is what it is going to JOKS is going to come into picture, and that is why JOKS become pretty critical in production or in any authentication cycle, because JOKS enables you with the stateless token validation, zero trust architecture, high performance APIs, and then secure key rotation without downtime. And that is where this is pretty important for any authentication principle. So now since we understood this JOKS principle, right? So now the step 9 and 10 is pretty much clear for us. Now, signature validation, which is again in the step 11, which you can see here, right? So this API internal setup is that one. Now, this JOT signature using RS-256 algorithm basically to validate this and ensures that token was signed by the correct private key. And if this step fails, right? So what happens? This request is rejected immediately, and then that if succeeds, then that issuer and the claim validation, which is in step 2, which comes into the picture, like who is the right issuer, the audience, the expiry time, and the NBF, like which is not before like the valid time window basically, right? So and these are the factors which is going to come into that step 12 itself, right? And this prevents token reuse, token forwarding, and audience confusion attacks as well, right? So that is where this is what is it's going to validate. Now then API again is going to do this identity mapping, which is your step number 13, right? And that is where map claims identity is coming into the picture. So now the API converts claim into an application identity, which is nothing but your user ID, roles, scopes, 10 and 10 for. So, messages like this and claims like this is going to be part of that. So this identity exists only for this request. So no session is created. So this is pretty important. So this is the piece is going to exist for this identity only, and that exclusively for this request. No session is going to be created. Now after that, what happens is like that authorization enforcement comes into play, right? Which is this is step 14, which is going to come here, wherein this is where your authorization principles comes into play, which is going to be the role check, and then the scope check, and then there is going to be a policy based rules. That means this is where criticality happens, like JOT does not authorize anything, the API does. So this is the most important line which you need to remember here. JOT does not authorize anything, the API does, because this is the internal API setup which is going to check for the real role checks, scope checks, and policy based rules. Now under this step 15, what we are doing here, right? So now if everything is succeeded, that is where API, which is that and client app interaction is happening, right? And this API returns the protected resource to the client app to access to get it successful access. Otherwise it is going to return you the response like 401 or 403. So this is in nutshell like how this entire flow from OIDC perspective, like right from the beginning, from the user actor, and then in between, right, the client tag could be anything, and then how it is trying to access to the protected resource comes into play. And this is, summary in 15 steps, like how do you achieve that. Now in the next video, what we are going to do is we are going to have this implementation and see that step by step what we have seen in this infrastructure diagram, or rather sequence diagram. Having said that, let's jump to the next video.